Now that you've seen how easy it is to convert from trig form to rectangular form, we need to go the other direction. We need to be able to convert from rectangular form, which you see here, it doesn't have any trig in it, to that version that does have the trig in it. So the form of our answer is going to be r and then cis theta, or you can write the long form of that. This tells us to use radian measures, so you just need to remember that when you're finding your angle. So there are two things that we need. We need r and we need theta. There are actually 3 steps to finding this information. And the first step is to draw yourself a sketch. When you draw the sketch, a lot of times it helps you find r with less work. And the main thing it does is help you get the correct theta. So you don't quit when you find the reference theta, but you find the actual theta in the correct quadrant. So that sketch is very important. I advise you not to skip the first step, which is the sketch. So we just want to sketch this first complex number here. We just need a rough sketch which tells us what quadrant it's in, so we don't actually need an official graph here. If we go in the real direction, negative square root of 3, then that's going to be over here to the left, and then we're going to go 1, a plus 1 in the imaginary direction. So that's going to put us up here in quadrant 2. If I drop a perpendicular from the end of that vector right there, then I get this right triangle. This is the same type of right triangle that you've been using throughout this entire semester. And we can label the x direction as negative square root of 3. We can label the y direction as 1. Notice when we graph this, we're saying that this is the imaginary axis and this is the real or x-axis right here. So you don't put an I as a label on your triangle. That's already taken into account by the fact that we're graphing on a complex plane right here. Essentially is what we're doing. So we get this right triangle. Now we need to find the r, and the r is the length of that vector, which is the hypotenuse of the right triangle that we've sketched. So to find r, we're just going to say that's equal to the square root of x squared, and if you square that negative, it's positive. If you square that square root, it goes away, so that leaves us a 3 for the first term. That's x squared. And then plus y squared. If you square 1, then you have 1. So square root of 3 plus 1 is equal to the square root of 4, which is 2. So our r value here is 2. Then we have our cosine I sine, and we need to find the theta. To find the theta, you want to use the tangent inverse of the tangent value that you can read right off of the triangle. You're always going to have your adjacent and your opposite sides because of the graph that you do of the complex number. Remember that tangent is opposite over adjacent, so tangent inverse is going to be of 1 over negative square root of 3. The picture reminds us that we're in quadrant 2. We're going to use our hand trick if 1 over the square root of 3 is special, which it is. Remember, tangent's on the back of your hand. So have a square root of 1 finger on the top, square root of 3 fingers on the bottom. Flip your hand back over and you see that you're at 30 degrees for the reference angle. Remember, we have to be in radian measures, so think of that 30 degrees as pi over 6. But our sketch reminds us that this is the angle that we want because that's the angle that puts us in quadrant 2. The pi over 6 is our reference angle right here. So if we're at 6 pi over 6, which is all the way to pi, and we back up that reference angle, then that leaves us an angle of 5 pi over 6, which is clearly a quadrant 2 angle. So that's our theta there, 5 pi over 6. And 2 cis, 5 pi over 6, is the trig form of that complex number. Now let's look at example B here. This one, for some reason, people think it's going to be more difficult, but it's actually much easier, and you'll see this when you do that first step, when you sketch it. Because there is no real part, all that means is I'm not going to go to the right or to the left for the real part of the number, because the real part is 0. But I'm going to travel negative 3 in the imaginary direction. So my vector looks something like this right here. It goes down to this y value of, that should be negative 3. Remember that your r value is always positive, and r is the value from it's the distance from the origin to the end of that vector right there. So it's clear that the r value is going to be a positive 3 here. And then the other thing we need is our theta. And the theta, if we're on the lower part, the negative part of the y-axis, is going to be 270 degrees. In this case, we are in degrees. So it's easy to tell from the sketch what r and theta are without going through the same calculations that we had to do for r and tangent inverse on the previous problem. So this is going to look like 3 CIS 270 degrees.